friends. Today I'm back again with a new kind of an exploit that can be used against Windows exploitation system. It's a part of the series that I've been creating and working on for the last few days. In this case, basically, again, we are going to talk about how to use return-oriented programming. In this case, however, I'm combining the return-oriented programming with the SEH override. So usually, in the earlier case when I had shown you the return-oriented programming, at that point of time, I had a direct control of the EIP. However, in this case, I have a control of the EIP using SEH. But with respect to the SEH or structured exception handler, the problem is that you control the SE handler. However, the ESP points way behind, and as a result of that, it's a little bit trickier to actually execute the return-oriented programming steps. So, as usual, just wanted to show you that currently the XPSP3 machine that I have does have a turn on depth for all programs and services. So I'm going to make sure that just to show that we have the depth activated at this point of time. Now just want to show that again, just in case people haven't seen this. You have to go to Advanced Settings, Data Execution Prevention, and you can see that currently it says turn on depth for all programs and services except those I selected. You can observe that Internet Explorer has not been selected, which is what I'm going to be doing the exploit against. I'm basically using an ActiveX in Internet Explorer that's susceptible to an SEH overflow, and that allows me basically to control it. However, due to depth, I cannot directly execute the shellcode. So basically in this case, I'm going to use return-oriented programming to bypass the hardware depth protection or data execution prevention, and that way we can execute our shellcode. So just to give you a quick idea, I guess we had discussed about return-oriented programming. So in return-oriented programming, basically we usually create gadgets. The gadgets are basically nothing but some sort of instruction that can get executed followed by a return. However, with respect to SEH, you basically need to jump into your gadget train. Now in a direct return exploit, you do control the EIP and you do have immediately your gadget train after that. However, in the SEH case, the ESP is way far behind, and as a result of that, it's kind of trickier to actually control the gadget train directly. So usually for an SEH, if you had no depth sort of protection, you would usually call a pop-up return instruction and then do like a jump 6 bytes or 12 bytes and then basically jump into your shellcode. However, since you have the depth protection, which means that you cannot execute any instructions, you can only execute one instruction, which is in the SEH handler. And that's pretty much it. So in this case, usually for a return-oriented programming bypass for an SEH handler, what we need to do is find an instruction. So Immunity Debugger combined with Mona can give you, basically ROP instructions. In this case, I have found a couple of ROP instructions that are basically allowing me to add ESP with 814. So that's basically 814 in hex. Basically, that means I'm adding 2068 bytes, and similarly, I'm also adding ESP plus 50C, which is approximately another 1000 bytes. So in this case, what I'm trying to do is basically, since the ESP points way before the gadget train, in this case I'm going to call it, or the gadget chain, I'm trying to jump into the gadget chain. And to do that, I basically need an instruction that points to the gadget chain. So in this case, that's why I ended up finding this instruction, which is add ESP 50C, which is at 06464837, which will help me to jump almost 1000 bytes and then again jump another 2000 bytes to actually get to my gadget chain. So this is sort of the trickier part in case of return-oriented programming with depth protection on an SEH override. So in this case, what I'm trying to do is, as you can see, I have filled up my initial payload with add ESP 814 just to make it easier for me, so that I don't need to be precise about where the specific add ESP 814 is. And similarly, I have done the same for add ESP 50C. That way, this overflows and basically overrides the SEH uh, pointer with add ESP50C. Once that is executed, it jumps back in ESP. It's now pointing to one of these instructions, which is add ESP814, and once it does that, it basically overcomes and finally lands over here. And that's why I have indicated it's kind of hard to explain. It's basically like writing a small program in assembly using the instructions. So once I jump back over here, this is basically the return oriented programming payload, which is basically a NOR because I'm using return. Now usually in case of this technique, you can do two different things. One is called sort of sniper technique, where basically what you want to do is sort of reserve bytes for yourself. So I'm trying to use virtual protect, and virtual protect is where I'm trying to trying to use that as a function. Virtual protect basically takes four parameters. One is the virtual protect where it returns. The other is the first parameter, which is the address. The second, which is the size. Third, which is the flag, and fourth, which is the copyright address. So in this case, basically, virtual protect helps me basically to bypass the depth. What this does is in virtual protect, you would basically be controlling that specific address and letting the operating system know that you basically want the depth to be turned off. Now, however, you cannot hardcode the values. Also, in my case, there was an additional issue where the virtual protect was actually at a different address. However, due to character restriction, I could not have that character as a part of my actual virtual protect call. So basically, I had to use return-oriented programming to not only create the right parameters for the virtual protect, but then at the same time also calculate the right address using return-oriented programming. So that's why this program looks very thick and huge. So basically, as I was discussing, after we have jumped and got to those two returns, which were over here, the first thing that you want to do is basically save the value of your ESP into different registers. This is what the sniper technique is, what I'm trying to use, where I'm trying to preserve the value of ESP, and then basically using those two values as sort of references, I'm trying to push the right parameters for virtual protect. So in this case, I'm moving the first value from ESP into ESI, and then the second time I move it from ESI to EAX. So both ESI and EAX at this point of time point technically to ESP. And the third time I'm again moving ESP into ESI, because when you move ESI into EAX, there is a sort of a pop instruction which screws up the value for ESI. So basically in this case, I'm using EAX and ESI as reference. Once that is done, what I'm trying to do is basically calculate the and get to the address of where my shellcode would be located. So I'm adding ESP basically 3 times, and this basically allows me to jump over this specific section of code, which is basically, which remains to be static and in reference with respect to ESP. So I'm trying to make the ESP jump over this specific this code, so that it does not sort of get mangled up with the other ROP instructions that I have. Once that is done, I was getting to the point of where now EAX was pointing to ESP's address as well. So I'm basically increasing the reference address by 100, which is 256. So I'm incrementing it 256, so 500 bytes, and then that's where basically I'm gonna put my shellcode. So I need that address to be the first parameter over here to indicate that this is the address that virtual protect should make free of the depth protection. Once that is done, I'm basically using the ROP again to move that EAX pointer is now overwritten into the first parameter. So that's what I'm doing by doing ESI EAX exchange and then moving it 20 bytes and then finally using this kind of instruction where I'm trying to put the value of ESI, which is now having EAX, and EAX, which was pointing to ESI, to actually override the first parameter. Now again, I'm incrementing it by 4 so that I can override the next parameter. Again, I'm safeguarding the address of virtual protect in EDI. So that's why I'm basically protecting the second parameter's address is protected now in EDI. And now I'm again incrementing EAX by 6 times. And again, finally moving the value into the second parameter, which is the size. So I'm basically doing an XOR and calculating the size for that payload, which in this case I'm calculating it to be 2, 3, 4, 5, 6. So I'm pretty much taking 256 into 6 times is what I'm calculating the size of the payload, and then basically again I'm overwriting it with respect to the second parameter. Again, I'm incrementing it EAX by 4 now so that it points to the third parameter, do the same thing to safeguard the third parameter. And now I need to calculate the value of the third parameter, which is a flag, which has to be 0x40. So I'm doing basically an XOR with I have done XOR EDI over here and then exchange. So EAX consists of 0. I'm just adding EX with 40, and that allows me basically to control the third parameter. So again, the same thing, I'm exchanging it EX and EDI and moving the instruction into the third parameter. Finally, moving back to the return address now. So now the return address is basically the same thing, which is going to be the virtual protect's address or the return address after the virtual protect. So I need to basically decrement EAX certain number of times and then again exchange EAX and EDI. Again, I'm moving ESP into ESI, since ESP should be pointing to one of the clear nearer locations, and then moving ESI into EX. Again, I'm calculating sort of the address for the return instruction, which should be in the same zone for the first parameter that we had, and that's where the shellcode will reside. So that's basically the return address after virtual protect comes back, and that should be in the same zone for which you're using the virtual protect and sort of turning off the depth protection for that. So if it was like 00126789 and then you had 600 bytes of size, so that return address should be pointing within that specific address. So that's what I'm doing over here. I'm adding EAX with 40 again so that it points to that specific address, exchanging EDI and EAX, and moving to fill up the return address. So as you can see, I've moved EASI into EAX, which was having the ESP's value. So ESP is already pointing to one of the lower addresses. I'm just now adding it with 80 and 40 to point to sort of similar address that I must have put in the first parameter, and the same address is what I'm trying to put now as a return address also. So that would be after virtual protect. Then again, I'm decrementing EAX to point to the virtual protect's address. Now this is where the trickier part is, that I don't have a direct control of the virtual protect, because the virtual protect's address is supposed to be something as 7C40. However, I cannot add that specific instruction, so what I'm trying to do is adding EAX to virtual protect so that the address can be 7C80184. Now, unfortunately, I didn't have the earlier case to be adding correctly, so what I'm doing is I'm subtracting 42, 44, 42p from this address so that EAX would have the value for this, and then finally I'm adding that value. So if we had looked at the virtual protect address, it was something like 7C, let's go back up and quickly look at it. Basically it was 7C and then 1A and D4, and this was supposed to be a sort of an ASCII character set, 1A ASCII character. So this ASCII character is approximately the value. So when EAX is pointing to this and it adds to that 4442B, it ends up basically adding up to the address of virtual protect, which is 7C80184, and now we have the correct address of virtual protect. Once we have the correct address of virtual protect, again I'm just exchanging the instruction with EDI and moving that stuff into it. Finally, after that, once all the parameters are aligned and virtual protect is aligned as well, now what you want to do is exchange EAX and ESP and just jump to virtual protect, and once virtual protect executes correctly with the right address, then it will return back to your address, and then you can execute the shellcode, which is in this case basically pops up a nice calculator. So that's pretty much it. It's a fairly simple program once you understand it. It's basically, having one of the depth bypass functions to be put as a part of your gadget chain. Jump over that. Make sure that you preserve the value of ESP into different registers so that you can use it as a reference. Put the correct values now using the reference values or reference registers into the parameters. In case your address is screwed up, try to add or subtract correctly so that your address is correct for the workup function that you want. And once that is done, you basically jump to that function, and after that it jumps into your shellcode. So that's pretty much it in terms of explanation. Let's look at it from the actual action perspective. So I'm going to quickly give a break on the 50C address. Let me put that up very quickly. It's basically this address. So I'm just going to pull the file and drop it over here. As usual, it will ask me to allow ActiveX to run, which I'm going to say yes. And then when it tries, I'm going to jump into 50C, do yes, and so now it's paused. Let's try. So as you can see, it's already jumped to ESP50C when it's pointing right now, and then it's it's ready to return. So that's what basically my return handler was pointing to. So just to show that to you, let's look at the SEH chain, and as you can see, the address 0212F5E8 is pointing to 0646F37, which is what we have as 50C. So I'm going to execute that and execute for a while. Then it gets to ESP814. Then it gets to 50C, so that it keeps on executing that a couple of times. And then finally, this is where your push ESP pop ESI. So this is how the ESI register gets the value. It's doing a return pin. Now ESI and EAX is moved. So both, if you look now, ESI has the same value as almost ESP had, and now I'm putting that into EAX. However, the ESI gets screwed because of the pop instruction, and so I'm trying to balance that again by pushing ESP and popping ESI. Once that is done, I'm doing two returns. Now I'm just incrementing ESP. So if you look at the stack 24 times, so that let's see where the address is for. So it has already jumped over. So this is sort of the 7C 7E184. So this is where I needed 7C 80184. So that's the address that we are trying to protect, and then it's doing the same thing. So after doing that, as I've jumped, now ESP is pointing below 7C, so that this area is preserved, and then it's pointing to this, and then I'm just adding EAX with 100, or PVP just a balance, and 100 and return. So now EAX is pointing to an address. Now I'm doing an exchange of EAX and ESI, so that now I can move it into the first parameter, which is basically the very first parameter. Then I'm doing an add EX20. Now EX is pointing correctly to the parameter. If you look, the address is 0212F74C. And if you go up and 4C, so this is the first parameter, the second, the third, and the fourth parameter. And then we have the return address over here as well. So once that is done, it will do that, and then it does a return 0C, increments EAX 4 times so that it points to the next instruction. Now I'm preserving that in EDI, so EAX and EDI exchange, and then I'm returning again. Now again I'm adding EX and 100 and then making it point to the size, which is what we were trying. And so now it's 600 is the size. Again I'm exchanging EX and EDI, so now EX is pointing to that value, which is 75F0. I'm going to go follow that in the stack. So this is where the value is, and as you can see, I had overwritten the first address, which is one with the first parameter with the address of which area in stack I want not to have that bypass, and then next one is 58, so that should get overwritten now. And if you look over there again, so the size would be overwritten the value, so let's do that. Now the size would be 400 or 600, I'm sorry, so the size is now 600, and then similarly in the same things. And I guess I might have quickly given, but the whole point is that it popped up a calculate as I planned, and I must have done an F9 as opposed to an F8, but basically the whole point is that, yeah, I mean, this is how it will work. So as I explained, I keep on overwriting every parameter, and then finally when all the parameters are overwritten, I'm doing an ESI EX exchange. I'm making sure that the virtual protect address, in this case, one additional thing that I needed to do was to make sure that the virtual protect address is correct. So I had to do an addition as we had seen earlier with that, and once that addition is done, the virtual protect address points correctly, then you finally do an exchange EX and ESP, and then basically pop a calculate. So that's pretty much it. I'm going to show the same thing outside, so I'm going to close only debug so that we can see that the calculator gets popped up again. And you know, as any normal person would do, you'd go to that specific exploit, in this case the exploit explain, and then that's it, and there you go, the calculator being popped up. That's pretty much it. So this is basically SEH override and the ROP combined. Let me know if you guys like this. That's pretty much it. Thank you.